One. Oh, now it works. Fantastic. Good evening, everybody. How are you doing today? Yeah, fine. Excellent. Actually, it's not going to be HTTP, it's going to be REST. And I'll explain to you that there will be a lot of twists in the story, sad twists. About 3 weeks ago, or maybe longer, I was sitting together with 7 colleagues of mine, watching in disbelief a problem in our data center that I have proven with the Golang program. I didn't know what to think about that, either to be proud or to beat myself into into non-existence because I didn't know how to solve. But I had 6 other colleagues around me saying, Alex, how are we going to fix it? And I said, well, you know what? We have a latency problem. REST sucks. Let's try gRPC. I said, no way. And I said, why? And this story that I want to tell you is sort of a fun recap of a lot of boxing matches that we had, recapping gRPC versus REST. Do we need to do it or not? Before I will continue, guys, who of you have ever programmed integrations using binary protocols? Okay, I got some hands. So how many of you have programmed anything with modern protocols like REST, GraphQL, CQRS, Event-Driven API? More hands. Amazing, amazing. So, a question. Is text protocol better than binary? Those in favor say yes. All right. Okay, let me put this a bit in perspective. I was trying to think how to explain this. Let's rewind the time, and let's imagine it's 2001. By the way, who was alive in 2001? Okay, cool. So I remember a conversation I was having with the developer. He said, look, we have kind of this binary interface that we need to synchronize all the time. Why don't you just give me a kind of very simple method? I'm going to send you one thing. You will send back an array of strings. I will parse it, and it's going to be super flexible. Let's do a pub quiz. What do you think we would think in 2001 if you would come across something like that?
Not gonna work.
Okay, not going to work.
You're an idiot.
Yeah, exactly. You're an idiot. Because in 2001, we just didn't do it. We were very fond of binary protocols. So how did we get out of that and shooting ourselves with a latency? Well, there are reasons for it. Before we'll continue, for those who don't know me, my name is Alex. I'm solution architect. And what this means that I have spent the last 25 years working with every imaginable technology, and after doing all this hard work, my full stack has been reduced to PowerPoint, Outlook, and the last element varies from a company to the company that I work for. It's either Slack or Confluence. So if you enjoy working with Slack and Confluence, your architect is for you, please apply. Before we continue, do you like REST? It's a tricky question. So who likes REST? Ah, okay. And who doesn't? So you come across a requirement to integrate with a not so good API. And I tell you it works in a RESTful way. So does it give you a warm feeling? Does it give you a warm feeling now? Now, you have built a massive infrastructure and your manager runs into the screen of why is it so slow? By the way, this is a generated image. Yeah. And finally, one day somebody comes across and says, UFA is a hall of shame. I did it myself. I was sitting next to the person, or to the manager, said, look, I have interesting news for you. You know what is the second most used return code in our all API infrastructure? I said, no. And then it's 404. I said, Do you know by how much? I said, yeah, by 40%. You know, if we're paying million, that if we remove 404s, we can actually buy ourselves a team of 5 engineers. You said, oh, I didn't look at this way. But it doesn't end here. Do you see a problem? As a Golang developer, who sees a problem? All right, for the rest of us guys who was here. Yeah, and if it gets like this, do you see it? So do you really like REST? Now, Well, obviously, there is a reason why we're here and why we're discussing gRPC. This is REST. And actually, it has a reason that we like inventing tech, but we hate using it because we're bad at it. So because we're bad at it, we keep inventing new tech and we keep selling this to the customers. So what has been going on all this time? It started in the 80s, of course, with Sun inventing RPC as we know it. And then there was 1991, Corba. Has anybody heard about that? Wow, impressive. And then there was year 1999. I think most of us would be starting our career by then. And then this thing happened, Ajax. When I said Ajax, who thought I was talking about football? Okay, cool. But we're in Rotterdam. It's not okay, we do this. And 2 years later, Microsoft came in with MS Soap Toolkit. So, you know, this something to wash your hands? Okay? And then they came up with two interesting things. Worldwide Consortium, web, by the way, and WSDL. Well, actually, that meant to replace another evil invention as Gmail. Who knows what Gmail is? Well, we have few people from the crowd. So XML was great, you know? Kind of 20 years ago, it was like, you know, the posh. But then something happened. A year before, a dude has invented the REST. And this is where things started, you know, trickling down the problem lane, because we started inventing APIs, but people who will research our technology will say, well, it all started in 1995 when JavaScript was invented. And then later on, when this thing got invented. And pretty much this architecture has been replaced with this. We took the least performant protocol and we put the most expensive serialization and deserialization structure so that we can invent this problem. Yeah, so keep alives. What are the two problems with keep alives in the HTTP protocol? Can you guys name them? Handshakes, yes. Another one. Well, there are two distinct things that people get wrong. The first one is you're correct. It's trash in service. You disable keep alive and you keep opening and closing connections. It's bloody expensive. And there is a reverse problem. If you keep the connection open and you don't use it, well, then the server terminates it. And there's no way to know it. I do remember solving exactly this problem that a huge bank would have a bug. Our payment system gets stuck after lunch. Why? Well, because the client, which was making the API calls, had TCP pulled inside for longer than the server was waiting. So after lunch, when people will make connections, you have a lot of pulls, they will close. And at 1 o'clock, nobody can get their transactions done. Well, how impressive is it? Yeah, and as I mentioned to you, our civilization is actually drives to the point where it's been defined by JavaScript and JSON and all technology around it, because if you look at this as a perspective, do you know what is the difference between undefined and null in JavaScript? Nobody. From a perspective of JavaScript, are these the same objects? No, they're not. JavaScript has a very funny thing that they have something which is undefined that didn't exist and something which is set to null. But does Golang has it? No. Okay, so how do we work with it? Yes, we can work with maps. But on the flip side, there is API landscape that we have invented to help ourselves to work with these tools. And I'm still talking about REST, by the way. How many of you recognize the things that you're working with? You see it? Yeah. All right. So gRPC, or Google RPC, and REST. REST is a horrible protocol, or maybe a good protocol. Doesn't matter, depending how good you are with using it. And when I was discussing this story with Vijay, I said, well, you know, maybe I can talk about gRPC versus REST. And I thought, well, no, maybe I can make it a bit different. Maybe we can talk about gRPC plus REST, just to make it fun. And then I ran into the problem that actually I figured out this is an empty talk because there's nothing to talk about. Let me show you the excerpt from the tutorial of gRPC, which actually, on this screen of text, lists all the features that they have. So you get your standard RPC, you get server-side push right in the box. So two most use cases implemented right there. You can just do it. Then you have what I call a server-side querying. So you keep streaming something and then server tells you back. And then bidirectional chat. Cool. That's a protocol. I was talking to my friend who's working in reputable financial institutions. Said, well, tell me how you guys like protocols. I said, we absolutely hate it. So gRPC is horrible because it has this. I said, all right. And what about these guys? We started in 2010 with, contract first deployments, documentation, RAMLs, etc., Swagger. By the way, in some companies they like use Pact, so you really describe your interface first, right? So we should be doing this all the time. And then the second one, when you actually take your protocol specification, you get interface defined for you by the compiler. Isn't it beautiful? So in fact, all the difference between gRPC is REST is right here on this line. The compiler gives you the list of methods that you actually have to do. You don't have to second guess. Isn't this nice? And two most exciting use cases, just make it a straightforward call. They all fit on the screen. This one, type safe. Type safe, you don't have to guess, you don't have to do this mapping, it's just there. And tooling, I'm a big fan of IntelliJ Stack, so they have support for gRPC right there. It's like, you just type it in and it works. And I started thinking, well, the title of my talk is gRPC versus REST. Difference? The difference? There's none, right? And then I said, well, it would be, of course, a shame if I would come up to you and say, well, you can just take out REST if it doesn't work and throw in gRPC. So I had to Google, I had to find something that would prove me wrong. I found this exciting article, and I decided, well, let's take a look at what they say, how Amazon thinks about that. I spent probably last 10 years working in corporate environments who work with REST and gRPC, mainly with REST rather than gRPC. And there is this interesting idea that you don't need any software. Well, it turns out you do, and you do quite a lot. Well, we don't want to talk about it. Because in the REST world, we also use API gateways. Who is using API gateways to handle REST traffic? Anybody? No? Who is working in corporate environments where we have centralized API management team? All right, we have one person. And do you like it? Do you like the services? All right, okay, don't worry, you're not alone. We're all the same. I also used to run the API management system, and I know how painful it is. So the second thing that article says, synchronicity. So REST is synchronous. Well, not necessarily. It's all about the libraries that you use. There is a reactive programming paradigm, so I don't want to dive into that. Guys, if you want to talk about that, let's catch up. But then you can use it in the same way for REST. You can use the same thing for services. It's just how you approach doing your client-side to server-side applications. There is another, though, very interesting difference, which I think we get lost a bit in this hype that everything should be REST. A REST protocol, if you look at it, it's pretty much entity-oriented. So if you have a domain which nicely maps on hierarchical structure, you're golden. But the question is, do you have it? I don't. You have kind of a hierarchy which actually doesn't really fit into this, and you always go into the kind of interesting discussion, well, is it put, is it patch? By the way, there is undefined nullability. gRPC doesn't solve it, but it makes you more kind of straightforward answer. Well, I have a server, I want to fire off something there, I'll just send it. And it's beautiful. Another interesting subject, documentation. There is a belief that if you take a Swagger, you have a good documentation. It's roughly in the same ballpark that if you put something in the cloud, you are secure. Who thinks that if you deploy something in the cloud, you are secure? for things you're not. Well, it's encouraging to see that we're quite realistic about. In big corporate environments, documentation is probably the number one thing that you can say needs to be improved, because it is always inaccurate. And no matter of Swagger spec can actually save it. So it's not down to the standard itself. It's more down to how intelligent people are who are using it. And perhaps the pain point, flexibility. REST, and you have to admit, it's damn flexible. It makes it very easy to stuff in just about anything because, well, you can declare additional attributes, put their objects, and that's it. You can send stuff across the board. It's very easy to define it, but it's also very easy to define something which you cannot use. Put yourself in an application. What is the use of me to get attributes that I didn't know what they're meant for? Can I trust them? What are the range? How am I supposed to use it? It becomes a holy war. So neither gRPC nor REST can guarantee avoidance of this. It's not a protocol thing. It's how well you do your job. It's how well you plan your releases. It's how well you take care of customers. Because if you don't, well, this is what happens. So it's gRPC REST, doesn't matter. So what does actually gRPC solve compared to REST? Asked my friend. He said, well, you know what, Alex? There is one thing in gRPC which is damn different from REST. And this one is speed. He said for ultra low latency, it is just amazing because it according to his calculations, it is 6 times as fast for microservice to microservice communications. I said, all right, I totally see that, but will it actually speed up a badly written backend? I said, Alex, shut up. So in the end, we kind of made this circle to say, well, you know what, there is one common thing in gRPC. It's down to the quality of the individuals that define the APIs and define the implementations. To avoid this, taking that API is a hall of shame. And gRPC or REST doesn't really matter. So, of course, I'm a solution architect. So my job is to define strategy, and my job is to motivate people. So what I really hope to achieve in this first conversation of the evening is to motivate you guys to ditch REST, do this with gRPC, and then ditch it again. So this is, trust me, this is a golden plan that nothing can go wrong. I'm a solution architect. Thank you for having attention, and yeah, go Kraken. Okay, so I will be happy to answer questions if you have. Yeah, please.
Do web browsers support gRPC yet?
No, browsers do not support gRPCs. Mobile devices do. And if you take a look at typical considerations that you think about load balancing, about security, then gRPC out of the box does give you things. Of course, if you want to achieve massive infrastructure, then you need to take a look at specific gRPC proxies that actually support it. There is HA proxy, Envoy, and there are a few others, plus Google, that actually can allow you to sort of, spray this across. Yeah, kind of in that respect is you can totally do it. You can use it on mobile devices, but there is a catch, of course. It is sort of, HTTP 2 connection, and it's like, it's pretty much dependent on what kind of use case you're using. The server in gRPC can be configured to send go away signal so that it will kind of tell you, well, go away, disconnect. This is the critical difference between kind of how you implement HTTP equal to the server and kind of how gRPC does it. So which one is better? Well, depends on your use case. I would say that if you have a case that you want accidental, let's say, call, then REST is still better because it does not require you to build a connection. It doesn't require you to build this logic that, okay, I'm still connected. You can just fire off, get some JSON, no problem. So it works for that. When you get into the kind of ultra, let's say, low latency communications, then it becomes a different ballgame. I have answered the question? Yeah. Yes, please.
Yeah, question, how in practice in Go you organize your code? So you have these proto definitions and
Yeah.
you generated some code.
Yeah.
Do you define it as a separate module and import by every consumer, or you make it a part of the project? How you do it?
Excellent question. So it pretty much indeed depends on how you structure it. Well, it's a pity that I don't have this example with me. You begin by writing protocodes. Kind of, it's actually a file that you put in kind of package in your project, and you need to run a protocompiler and to compile into that. Typically speaking, what you would get stub implementations that will be written in place, and you can commit it into your GitHub. If you look at examples that gRPC authors provide, this is exactly what they do. They have a proto and they have a matching output of the compiler. From that moment, it becomes just a Golang code that you import. There's kind of really no difference that it's like, becomes the same as anything else. So it depends, what kind of communications do you have. If you have, let's say, microservices that you control, it makes sense to probably kind of put them in one project, and you sort of have a central module, and then you kind of create microservices. If you share in the cross, well, either you put, let's say, module on GitHub, for example, or kind of distribute any other ways. It just becomes Go code distribution problem. Correct? Okay. Yes, please.
Yeah, how do you integrate legacy or strange clients that cannot speak gRPC into a larger, like, gRPC environment?
Excellent question. That's why I said it's not gRPC versus REST, it's gRPC plus REST. So if we look at a sense that gRPC is actually not really suitable for, let's say, certain clients and certain type of integrations. If you have a kind of very weird application, then it probably makes sense to say, hey, for this particular thing, I want to put a REST. And if I have something that I really require low latency, that I'm going to also support the gRPC endpoint. However, if I would go back, just let me quickly show you this. Right. So look, this is the example of gRPC endpoint. Okay. And actually, with what you can imagine, with a bit of refactoring, let me see if I can get it. No, I can't. Let's say the second line, say hello. All right. All of that is still boilerplate. It's just what your compiler has generated to you. But the method internally, it's, well, you can do whatever you want. So technically speaking, you can put into the same executable, two flavors of it. You can have an HTTP starting something, and you kind of your functions that will do this JSON on marshalling and convert this, and then call in a method. It would totally work. In fact, arguably, you can just try calling this directly, and it should also work, because at that moment it's just just a function. So you can have them both in the same thing. Make sense? Yep. Do you want to try it? Do you want to try and speak at the next meetup? That's a yes. Well, you see, I have already, found a speaker for you. Yeah. Guys.
Okay, maybe it's last.
Yeah, no, go ahead. Yeah, please.
You often hear how I would test my API.
Yeah.
So Postman is the easy solution.
Yeah.
CURL is the
Yeah.
easy solution for REST.
Yeah.
But when it comes to gRPC, do you compile and build like a dedicated software just to test, by test, or?
Just a second. Let me find this. Well, easy implementations you can get out of the box with, for example, with IntelliJ tooling, right? The truth is that API testing in the field, especially, this is a very quirky subject. How I would personally do it, I would start writing down scenarios. Sorry, I'm right now going into a completely different kind of trivial answer, but just bear with me for a sec. The weakest problem in all API testing is that people focus on parsing JSON rather than what business case does it solve. So what I personally find is that the best way of testing complex API integrations is to write behavior-driven test scenarios. I personally take Cucumber. Not everybody agrees with it, but this is my style. So to answer your question, yes, I would personally, if it is anything kind of tricky, I would write BDD-based scenario. What exactly I will choose to do that? Will it write, for example, Java code or Golang code or Python code? Pretty much depends on, let's say, on the circumstances. BDD Cucumber is interpreted with library, so you can just do it. So technically speaking, you can have, let's say, API testing BDD-driven with the gRPC. But indeed, this is a bit sort of, Achilles feet of gRPC because kind of it's not really, let's say, very well consumer facing. So we don't have that many tools. So probably you have to do this do it yourself. Is it a good or bad thing? I would say it's a good thing. Yeah, we had one more question in the back.
Sometimes the connections
Yeah.
gRPC are line running.
Yeah.
So how would you handle load balancing and zero downtime deployments? Basically, specifically on Kubernetes clusters.
Yeah, right. This is a very excellent question. To answer it, they have a solution which is called the maximum length of the connection. What will happen if you set the maximum length of the connection is that the server will force long-running clients to disconnect regardless of whether or not they are connected. It is a bit of the advanced use case, how to do that, how to, let's say, take a pod offline and kind of drain the connections out of it without actually breaking anything. But it is totally possible. I do not remember all the details of exactly this example, but then it is solved by the combination indeed of the health probe and this technique that you signal to the pod. That's it. You kind of prepare to die, and then you simply let the server shut down and exit, because it will kind of send go away connections. Gentlemen? All right. Okay. Yeah.